Well, Lauren, I'm doing this podcast because I don't want to have steered you wrong when I was working with you yesterday, when I was tutoring you yesterday. Now, I'm not sure of the problem that we had yesterday, so I did it out of memory. It might be a little bit different than what I have drawn on the board, but it's going to be very similar. Even if the numbers are a little bit different, it's still going to be, it's still going to apply to the problem that we were doing yesterday. So what I have here is a function, and if I write, so let's call this function f of x. So if I call this function f of x, then the domain of this function is going to be the range, the values of x's that I go from. So over here, this would be -6, and it goes all the way to +6. So that is my domain. My x has to fit within that interval. So if I write that as in interval notation, then that would be -6, 6. Now if I do the range for this one, then if we look at the graph, the highest value that y ever reaches is right here at, I think that's 5. 1, 2, in fact, let me put the numbers in here so as I'm doing it. So I know that this is -6, this is 6, 1, 2, 3, 4, 5, so that would be 5, and this looks like it's -2. So if I'm solving for the range here, then my range is going to go from the lowest value that y could be is -2, and the highest value it could be is 5. So that means that my range in this problem is -2 to +5. So that's that's the domain and range of the actual function. If I want to do the domain and range of the inverse function, I don't really have to do anything really with the graph itself. I can simply switch my x and y. So in the inverse function, the domain is going to be -2, 5, and the range is going to be -6, 6. So it's going to go from -6 to +6. So that was really all that was asked in that problem. Now, when we did the reason why I wanted to do this specific problem is when we did this yesterday, I told you to take this function and break it into two functions, so a piecewise function, because from here to there, actually if I draw that equation, it would be y equals x plus whatever the intercept is, and if I follow this up, so this is 5, 6, 7, so it's actually going to hit the y-axis at 7, so that would be the function there. And if I figure out the equation for this, again, it's a -1. It's not perfect. My graph is not perfect, but it should actually, the way it goes through there, it should actually go through this point right there, that point, that point. So it is a little bit off. But the equation would be y equals -x plus 3, because the intercept in this one would be 3. So -x plus 3. And you can do it that way. You can actually figure out the inverses simply by changing your x and changing your x and y, and then solving for the new y in both of these. So the inverse, if I take this one, the inverse of that would be if I switch the x and the y, I get x equals y plus 7. If I solve for y, it's going to be x minus 7. So if we call this the function, then this would be the inverse function. And another problem that we did had to do with if you take the function of an inverse, and this is a good example because if I have, let's say, a function, and then from that function I go to another function. Well, let's say this function, f of x, equals what I said it was over here. So f of x equals x plus 7. And then f of the inverse of f of x, so that would equal, coming over here, that would equal x minus 7. So you can see that whatever number I put in here, if I do a composite function, meaning I'm going to do the function and then the inverse, or the inverse and then the function, it actually doesn't matter which order these things are in. I'm still going to get the value that I started with when I get to there. So for example, if I put a 2 in here, well then I'm going to do the function. 2 plus 7 will be 9. So I'm going to get 9 there. Well, now I put 9 into this function. 9 minus 7, and I get back the 2. Another function, inverse function, that I actually referenced yesterday was that we have a function, let's say we have a parabola function. So we have y equals x squared, or the function equals x squared. And to show it, I'll put it over here. So y equals x squared. Well, the inverse function would be if I switch my x and y, and I write x equals y squared. Now, if I solve for y, taking the square root of both sides, I get this. So what I have here is this is the function, that is the inverse function. So here's the function, and then let's have the inverse function. And again, it doesn't matter what order you do these in. But if I do the inverse function, it's going to equal the square root of x. So again, if I put a number in here, let's put 5 in. If I put 5 in, then 5, when I square 5, then I'm going to get an output of 25. Now I'm going to take that, and that's going to become the input for the next function. Well, the square root of 25 is 5. So what I started with is what I end with. So again, that one problem that we spent a little bit of time on, where they had it written as it was either f of x, the inverse of f, or it was f inverse of f of x. We're going to get the same answer. In both cases here, the answer would be equal to x. So whatever number goes in, if you take the function and then the inverse of that function, you're going to get back the value that you started with. Now, there's another thing that I wanted to say about this particular problem. Instead of breaking this problem down into 2 line equations and creating a piecewise function where from here to here it's one equation and then it's one function, and from here to here it's a different one. So actually, if I look at my picture from -6, so from -6 to -2, it's going to be this function. And then from -2, so I guess I'll do it up here, from -2 to +6, it would be this function right here. But the thing is, that particular function that I drew there, that is actually a graph of an absolute value function. So what I could have done in this problem, I'm going to erase some of this stuff now. So what I could have done is my basic inverse function. And what I'll do is, well, let's see. I'll use another graph here to show you what I mean by an absolute value function. Your basic absolute value function goes, I guess I'll do it in a different color. So it goes here, and it doesn't, my cursor doesn't put it right in the corner where I want it. That's why things are off a little bit. And starting here and going in the other direction, again, I can't put it right in the corner, so let's pretend it's there. So what I just drew there, that's an absolute value function. So what I have drawn, if I were to write the equation, it's going to equal y equals the absolute value of x. Now, if I took this and flipped it over the x-axis, then the only difference between that and the function that would look like this is there would be a minus in front. So now if we look at this function right here and compare it to that, well, this one is concave up and this one is concave down. So what I know is that there would be a minus sign over here to convert it from this to this. Now, the vertex of this one is right at 0, 0. The vertex of this one is -2, 5. So we have to also factor that in. So if I actually do this, if I create, I'm going to run out of time on this. I can only do a 15-minute video, and it's getting close to 15 minutes. So I'm going to stop and start over, so I'm going to have to turn this into 2 videos. So I'm going to stop it right now and then pick it right back up.